Alright guys, so we're about to make a few plates for the Maker Mike show. These are plates for a 3D printer, and basically it's a family of parts that are very similar. Okay, so we have the bottom plate, we have the bottom plate back, and the bottom plate top. Alright, so this family of parts all uses the same stock material. So the stock is going to be 200 thousandths thick by 4 inches wide. Alright, so you got 4 inches, and the length of each one of these is going to be 22.5 inches. So it's going to finish up at 22.263. Alright, so first thing I'm going to do is I'm going to go over here, I'm going to go to manufacture, and I'm going to go to setup. I'm going to go ahead and set up my stock. I have offset side and offset top. Offset side, I'm going to do 0.25. Actually, offset side, I'm going to do 0, and stock top 0. Now there is going to be some stock right here that hangs off, but I'm not going to worry about that. And what I'm going to do is I'm going to go ahead and I'm going to set up my model orientation. I'm going to select my Z-axis. So I come over here, click this check mark, click on top. Then I'm going to select up my X. This is going to be my X-axis right here. Next thing I'm going to do is I'm going to select my origin. I'm going to do a box point, model box point. And I'm going to select right here for my origin. Now I want my X going to the right, so I'm going to come over here to flip X and check it. Now when I did that, it moves my origin over to this corner, so I'm going to go ahead and reselect my model box point and put it right here. Let's go ahead and click OK. I'm going to rename my setup Op1, and first thing I'm going to do is I'm going to do a 2D contour on this side, and then do a 2D contour on this side. So let's go ahead and start with our left 2D contour. So I'm going to go 2D, I'm going to go 2D contour, and when I hover to select the side, it wants to select the whole parameter of the part. So I'm going to hold my Alt key down, which will let me select just this one area. And now I'm going to go ahead and set up my tool. So I'm going to use a 1/2 inch end mill. So I'm going to go to my tool, and I'm going to create a 1/2 inch end mill. So I'm going to make this tool 1. I'm going to name it 1/2 inch end mill. I'm going to go to cutter. I'm going to select flat end mill, and in diameter I'm going to type in 0.5. Shaft and holder I'm not too worried about. Speeds and feeds, I'm going to go 1500 RPM at 15 inches a minute. Now I could go faster, but I'm going to start off at 15 just because it's one piece. And my plunge rate, we'll go ahead and leave it at 5. Post processor, tool 1, sounds good. So I'm going to hit OK, and I'm going to select this 1/2 inch end mill. Then I'm going to go to my heights. I'm going to go ahead and put this in front view, and my reach clearance height, I'm going to make 0.1, retract 0.1, top height 0.1, stock top 0, and my selected contours, I'm going to go to absolute and tell it to go minus 0.25. I'm going to go to passes, and what I'm going to do is I'm going to add in rough passes with a 50 thousandths maximum step over, and number of step overs I'm going to go 2. I'm going to go to linking. I'm going to change my sweeping angle at 180 degrees, and I'm going to go ahead and hit OK. Alright, so if I put it in top view, you can see that the cutter does this little radius right here before it leads in, okay? So what I'm going to do is I'm going to change that. I'm actually going to make this my lead-in radius at 0. Linear lead-in radius 0. I'm actually going to put this at 0 degrees. My linear lead-in distance, since I'm using the 1/2 inch end mill, I'm going to go to radius plus some, so I'll make it 0.3. So now if I zoom out, I have something that looks like this. And what I want to make sure is that this line right here, that the end mill starts before where the material actually starts. Alright, so everything looks good. I'm going to name this left cut. And now I need to go over to the other side and do the same thing. So the easiest way to do this is just right click right here, go to duplicate, and I'm going to rename this right cut. So all we got to do now is edit this right cut toolpath. I'm going to go to geometry, deselect the previous geometry, and now I'm going to hold my Alt key and select this edge right here and hit OK. So I have something that looks like this. Got my left cut, got my right cut. Alright, so the next thing I'm going to do is I'm going to come in and I'm going to cut this pocket. So I think I'm going to go ahead and use a 1/4 inch end mill to cut out this pocket. And we're going to use let's go ahead and save this. I'm going to use a 2D contour. So I'm going to go to Tool. I'm going to create a new tool. I'm going to go to the General tab. I'm going to name it 1/4 inch end mill. I'm going to go to my cutter, use a flat end mill that's 0.25 diameter. Shaft holder, not worried about. Speeds and feeds, I'm going to go 3500 RPM at 15 inches a minute. And I'll go ahead and leave my plunge feed rate at 5. Post processor, tool number 2, sounds good. And I'm going to select OK. I'm going to hit OK again. Now I'm going to go to my geometry tab and I'm going to select this chain right here. Everything looks good. If I wanted to cut the outside, I would click on this arrow, but I don't. I want to cut the inside. Heights. Okay, so I'm going to put it in front view so I can see what's going on. Retract height, I'll make 0.1, stock top 0.1, top height 0.1, stock top 0. And my bottom, I'm going to put it in absolute and go minus 0.25. Now the plate is 200 thousandths fit, so 0.25 is an extra 50 thousandths right there. I like doing that because it ensures that if there's a radius on the end mill, that it still cuts to full depth. Alright, so number of passes, let's see, let's go ahead and put this on multiple depths. And 40 thousandths per depth of cut, sounds good. Let's go to linking, horizontal lead-in radius. Let's go ahead, let's try out 25 thousandths. I think that'll work. I'm going to hit OK. I'm just going to use it at the default settings. I don't usually do that, but I'm going to do it now. Alright, so what you want to watch out for is we want to make sure that the tool doesn't feed in and we don't put any kind of significant force on the tool that could break it. So we have this lead-in radius that the tool pretty much sweeps down and leads in at a radius, okay? We could have problems with that. I'm going to zoom in really close and I'm going to simulate this. So the tool comes down, leads in at a radius to 50,000 depth, 40,000 depth of cut, and then it starts taking its pass. It's going to look something like this. Comes out. It's going to back up, lead back in. And everything looks pretty good. As you can see, I'm actually going deeper than the plate actually is. That's to make sure that I actually cut through. If you go the exact distance, sometimes you'll find yourself with a really big bird. Alright, so everything looks good. I'm going to close this out. I'm going to rename this operation Pocket. Let's go ahead and hit save. Alright, so I'm going to start off by measuring these holes here. So I have a diameter of 0.177 here, 0.177, 0.138. Now I have a bunch of these plates to make, so I'm actually going to do something weird here. Not only do I have the 3 plates I have to make for the Maker Mike show, but also I have a handful of plates that uses the same stock material to make for myself. Now, one thing, each one of these plates has a wide range of different drills. Okay, so I'm gonna do something weird I don't usually do. I'm actually just going to drill each hole with the smallest diameter, and then come back to the drill press and actually drill it out 2 sides. Now the reason why I'm doing that is because I have a bunch of plates to make that uses a wide range of drills. Okay, so my setup process could take a long time. So what I'm going to do is I'm actually going to find the smallest drilled hole, which should be 98 thousandths diameter. And I'm just going to drill a 98 thousandths through each one of these, and then rechase everything on the drill press. That's because I have to make one of each. Okay, I actually have like 10 different plates I have to make. This is just one size. If I wanted to set each tool, my programming time and my setup time and operation time would drastically actually increase. So I'm trying to make things easier for myself, and I'm actually just going to cut everything at 98 thousandths. If on the drill press, rechase everything to the right diameter. It's a lot faster that way. Now, if I was running 5 pieces, I'd probably do it differently. If I was running if I was running 5 or more pieces, I would do it differently. But in this case, it's one of each, and my setup time is going to increase with all these different hole sizes. So let's close this out. So what I'm going to do is I'm going to go to drill. I'm going to go to select my tool, and I'm going to create a center drill. Center drill. I'm going to select my cutter. It's going to be center drill. My diameter right here is going to be 0.125, and my diameter of my body is going to be 0.25. Feeds and speeds. I'm going to go 1200 RPM at 4 inches per minute. My plunge feed rate, 4 inches. Post processor, let's make this tool number 3. And I'm going to hit OK. Let's go to geometry, and I'm going to select each one of these holes. Okay, now I want to do it in an order that makes sense, where the tool doesn't have to travel here and go way over to this hole. So I'm going to do these just right in line. So I'm going to select each one of these holes right in line. So I'm going to select this hole, and so on.